video, we are going to cover section 4.4, the equidistant theorems. After studying this section, you'll be able to recognize the relationship between equidistance and perpendicular bisection. Now, in order to talk about equidistance, we first have to establish what distance is. So in geometry, the term distance has a special meaning. The distance between two objects is the length of the shortest path joining them. And we know the shortest path joining two objects is a straight line, which is a postulate. So a line segment is the shortest path between 2 points. So in my diagram, I have points R and S. The distance between points R and S is the length of the line segment RS, or RS. So we usually measure distance in feet, inches, centimeters, meters, things like that. Now, when I talk about equidistant, if 2 points P and Q are the same distance from a third point, then X is said to be equidistant from P and Q. Equidistant meaning equal distance away. So the segments PX and XQ would be congruent, and that would also mean that X is equidistant from both points P and Q. Now, looking at my 3 diagrams, we've seen a lot of these diagrams in our homework problems. And these diagrams have something in common. In every single one of them, points A and B are all equidistant from points C and D based off the tick marks. Now, in this case, we can show that line AB for each diagram is the perpendicular bisector of line CD. Now, the perpendicular bisector of a segment is the line that bisects and is perpendicular to the segment. This leads us to a theorem. If 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. I can prove this theorem using the definition of perpendicular bisector and congruent triangles. So in my diagram, I'm given that segment PA is congruent to segment PB. Segment QA is congruent to segment QB. I want to prove that line PQ is the perpendicular bisector of line segment AB. Notice in my diagram, I have line segment PQ is congruent to line segment PQ by the reflexive property. This would make triangle PAQ congruent to triangle PBQ by side, side, side. Now that these triangles are congruent, I could say that angle APQ is congruent to angle BPQ by CPCTC. Then if I call my middle point, say point E, I could say that segment PE is congruent to segment PE by reflexive property. Now my smaller triangles are congruent, so triangle PAE is congruent to triangle PBE by side angle side, which would then give me angle AEP congruent to angle BEP by CPCTC, and I know if 2 angles are sup and congruent, then they're right angles. I also know that segment AE is congruent to segment EB by CPCTC. Now that I've shown line PQ is both perpendicular and bisects segment AB, I know it's the perpendicular bisector of the segment. Now, if I want to use this theorem in a proof, I can use this shorthand version. So if equidistant, this is a general diagram that I can draw for equidistant, then I am the perpendicular bisector. There is a converse to my equidistant theorem. So if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. So looking at my diagram, I want to prove that segment PA is congruent to segment PB if PQ is the perpendicular bisector of segment AB. So if PQ is the perpendicular bisector, I know that these are right angles, and I would also know that AQ is congruent to QB. I know that PQ is congruent to PQ by reflexive, which would make my 2 triangles congruent by side angle side. If my 2 triangles are congruent, then segment PA is congruent to segment PB by CPCTC. Now that I've shown segment PA is congruent to segment PB, I know if a point is on the perpendicular bisector of a segment, then it's equidistant from the endpoints of that segment. Now, it doesn't matter where point P is. It could be anywhere on line PQ, and it's still equidistant from the endpoints of the segment. So it could be here, it could be here, it could be way up here. As long as it is completely vertical, so still perpendicular to that segment, it will still be equidistant from points A and points B. Now looking at our sample problems, I have the following givens, and I want to prove that line AE is the perpendicular bisector of line segment BD. In order to prove that line AE is the perpendicular bisector, I need to show that points AE or points AC are equidistant from the endpoints BD. Looking at my givens, I have angle 1 is congruent to angle 2. This would tell me that AB is congruent to AD, because if base angle is congruent, then my legs are congruent. And angle 3 is congruent to angle 4, so BC would be congruent to CD, because if base angle is congruent, then legs congruent as well. Now that I've shown that points A and C are equidistant from the endpoints BD, I have line AE is the perpendicular bisector of segment BD. Looking at this in my statements and reasons, I have my first given, angle 1 is congruent to angle 2. Then I had segment AB is congruent to segment AD, because if base angle is congruent, then legs congruent. Then angle 3 congruent to angle 4. Then segment BC is congruent to segment CD, which was the same step as 2. And now I have line AE is the perpendicular bisector of line segment BD, because if 2 points are each equidistant from the endpoints of a segment, they determine the perpendicular bisector of the segment. Remember, if I want to shorthand this, I can say if equidistant, again, this is just a general diagram picture that I can use for equidistance, then perpendicular bisector. Looking at problem 2, I want to prove that the line joining the vertex of an isosceles triangle to the midpoint of the base is perpendicular to the base. So in my diagram, that's line AE. So if I'm given that triangle ABC is isosceles, with line segment AB congruent to line segment AC, and E is the midpoint of line segment BC, which would tell me BE is congruent to EC, I want to prove that line AE is perpendicular to line segment BC. Looking at my diagram, I've shown that points A and E are equidistant from points BC. Therefore, AE would be the perpendicular bisector of line segment BC, making line AE perpendicular to that segment. Looking at this in my statements and reasons, I have my first given, triangle ABC is isosceles with AB congruent to AC. Then E is the midpoint. Because E is the midpoint, I have segment BE is congruent to segment EC. Definition of midpoint. Now line AE is the perpendicular bisector of line segment BC, because if equidistant, then perpendicular bisector. Looking at problem 3, I have the following givens, and I want to conclude that line segment BE is congruent to line segment ED. So looking at my givens, I have line segment AB is congruent to line segment AD, line segment BC is congruent to line segment CD, and that's all my givens. Notice I've shown that points A and C are equidistant from line segment BD, making line AC the perpendicular bisector of line segment BD. E is a point that is on my perpendicular bisector. Therefore, it would be equidistant from the endpoints of my segment. So that's how I can conclude that segment BE is congruent to segment ED, because E is a point on the perpendicular bisector. Looking at this in my statements and reasons, I'd have my first two givens. Then I show that line AC is the perpendicular bisector of line segment BD, because if I'm equidistant, then I'm the perpendicular bisector. And now I can conclude that line segment BE is congruent to line segment ED, because a point on the perpendicular bisector of a segment is equidistant from the endpoints of the segment. In today's lesson, we learned the perpendicular bisector of a segment is the line that bisects and is perpendicular to the segment. And our two equidistant theorems are, if 2 points are each equidistant from the endpoints of a segment, then the 2 points determine the perpendicular bisector of that segment. And if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of that segment. That's a wrap on today's video. We'll see you in the next one.